I'm thinking about this is I'm thinking that there's three of them. So the first is for categorical data. Categorical. So if my data is categorical, then there's really only one thing that I can use. This is proportions. So in this class, there's two different types of proportions. There is a population proportion. And then there is a sample proportion. Right. And they both are, I mean, they should be relatively similar, right? How would I figure out the proportion of people who got a ride to campus today? Oh, this class is
Stand outside of the notebook and have some here.
I have no idea what you just said.
Outside of the notebook?
Oh yeah, well if I wanted to do that for you guys in here, how would I do that?
Ask them.
I would just be like, how many of you guys got a ride to campus today? No, seriously, how many of you guys got a ride to campus today? Just one, two of them. So what I would do is, where would I put that underneath a sample, or would I put that underneath a sample or a population? It kind of depends, right? Let's say if I'm considering this classroom right here to be a population, then I'd have to put it here, right? If I'm going to consider you guys to be a sample of evening students, then I would have to put it here. My point behind saying that is how I calculate a proportion doesn't change. It is still going to be number of successes divided by a total. The only way that I'm going to know whether it goes under population proportion or sample proportion is more information. I need to know what it is that I'm describing, right? If I'm describing you guys as a population, then I'm going to put you there. If I'm going to describe you guys as a sample, then I'm going to put you guys here, right? So the description of the number is what's important, not necessarily the value itself. To calculate this one, well, it's the same. Still the number of successes divided by total. I'm going to put successes in quotes here. The reason why I'm going to put successes in quotes is because it's not really a success in terms of like, I mean, it's getting a ride to campus. Is that like a success?
Yes.
I guess on certain days it could be, right?
Exactly.
But I mean, in terms of life, well, how about this? If I wanted to know the proportion of people who have high blood pressure on campus, what would be a success there?
Good blood pressure.
No, actually having high blood pressure. Is that typically a success in life? It's like one of your guys' life goals are like, come on, high blood pressure, let me get this. Oh, dang it, it's normal. Rats. Guess I'll have to do less and eat fattier stuff. I don't know. But, so I put success here in quotes. Typically, because really what we're looking for here, we're looking for a characteristic of interest. Right, so what is going to satisfy that characteristic of interest? So that's a sort of an easier way to think about it. Let me see here. The notation for this. This is a lowercase p. The notation for this is one that is equal for the rain. It is literally called p hat. And yes, it looks like a hat. So this is typically a lowercase p. A little bit of a note here. Is this value, is this p here, is it a parameter or is it a statistic? Oh, that's statistics. I'm asking you guys to think about like past stuff, aren't I? I'm sorry. What is it? Statistics. It is not. Which means it has to be a parameter. How do I know that this is a parameter? It's really stupid. It's a population. What do people start with? P. Parameter always describes a population. This guy right here, is this a parameter or is it a statistic? describe samples, parameters describe populations. Also, note for this, how many parameters can you have? What I mean by that is, if I consider you guys to be a population, right? And what did I say? 2 people got a ride to campus, and there's 23 people in here. So 2 over 23 is the parameter here, right? The number of successes is 2, there's 23 people in here. So that number now describes all of you guys, and I'm considering you guys to be a population. Okay? So if I did that same question again, and if I did the same calculation again, 3 minutes from now, would that number be the same or would it be different? Be the same, and that would be kind of stupid to do it, right? But let's say that I want to do it again. And then again, then again, then again. Would that number change or would it always be the same? It would always be the same. How many parameter values can I have? There's only one of these. Because it describes a population. And if you think about it, the population is everything. So since this is a number that describes everything, I'm not adding or taking out any other information. Does that make sense? What about a statistic? So let's think about it this way. I'm going to ask, what did I say? 2 out of 23 people got a ride to campus. And then I know that there's another class on the hall over here a little bit. If I ask them, would they also be 2 out of 23 or would they be something different? Could they be 2 out of 23? Yeah. But do they have to be? No. Could they also be considered a statistic for all evening classes? Yeah, so they could be considered a sample. You guys are a sample. If there's another class on this campus tonight, then I could go and ask them. My point behind that is there one of these or are there many? Many. There's many of them. And that's usually the case. Parameters that there's one, statistics that there's many. And actually it's pretty interesting, but we can determine how these guys vary, right? How they change. It's actually kind of predictable, which is what leads us to the back half of the class, which is inference. But for right now, I just need you guys to know, statistic describes a sample, there's many of them. Parameter describes a population, there's one of these. This is a P, this is a P-hat. Alright, the second one. This one's much harder. This is the mean standard deviation. This is used for numerical data. Numerical data only. It can only be used in numerical data. It doesn't make sense to do it for categorical data. So, let me kind of break this out a little bit. The mean, this is an intent. This describes the center. Or I should say, it's an attempt to describe the center. It's probably a better way to put this, right? So this is a number that we're trying to get a middle value for. And then the standard deviation, this describes spread. So all this is going to do is just describe how spread out the values are. Right, so now I have a number that is going to summarize all the data, and in theory, tell me which one is in the middle. And then I'm going to have a standard deviation, which is going to describe how spread out the values are around that middle value. So let me start with the mean. What do you guys understand? Typically, people don't say mean. In fact, I don't say mean. Average? Yeah, this is just an average. How do you calculate an average? Yeah, you guys are like a terrible 5th grade choir. Unless you guys are trying to go in round. If you're trying to go in round, then that was pretty nice because you guys are a little early, you guys are here a little late. I mean, you can do like, I don't know, whatever that song is that we sang in round. What was it? What was the song that we sang in round in like 5th grade? like Twinkle Twinkle Little Star or Row 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 Your Boat or something? What was it?
I think nursery rhymes.
Hot cross. I don't think I ever played that one. Maybe. Anyhow, so the average. Like I said, the way that we calculate this, you add them all up, add up all data, divide by the total number. There's nothing new about this. To impress your bar friends, you guys know what this? This is a mathematical notation that means add. Add. Yes, it is a capital Greek letter sigma.
That's a sigma.
This is the formula for averages. I will never, ever ask you this, ever again. So if you didn't write this down, I wouldn't blame you. If you do write it down, then you better be using it somewhere. Otherwise, there's no point in writing it down. Because this literally just means this. And when I asked you, how do you calculate an average, nobody said sigma of x over n, because it doesn't matter. How do you calculate it? Well, you add them all up and you divide by the total. And that's literally what this is. I guess technically this should be this. And then I add the total there. Right, the n is going to be the total number. The x's are going to be the actual values themselves. So this is all this is. But to make life more complicated for you, because that's what I have to do, we have a population mean. I know. And a sample mean. And they are absolutely 100% different. Just like over here, a sample proportion and the population proportion, they are still different. Now how we calculate them are both exactly the same, but they mean completely different things. So, before I begin this, population mean, is it a parameter or is it a statistic? Parameter. Oh, that's much better. No more round either. And you guys said it with like gumption. Parameter, which means, how many of these are there? There's only one. And a very simple explanation of this, right? But I asked all of your guys' ages, and I don't remember them, but if I added them all up and divided by however many students are in here, that would tell me the average age of the class. Right? So then I'm going to consider you guys to be a population. If I did that same thing 5 minutes from now, would that age change? No. 10 minutes from now. No, it'd just be keep on getting the same value over and over and over again because it is a parameter and I'm not adding or taking out any other information. So there's only one of these. The notation. This is a really fancy mu. This is a really fancy m. This is the Greek letter mu. And I will actually say mu. Students will actually just end up calling it an m, which is fine. I understand that, but I will always say mu. Alright, sample mean. Parameter statistics. But you guys see where this is going. Oh, the blue's nice. Okay, the blue's nice. Like 4 classes. I have like boxes of those things, and like they give us 4 at the beginning of the semester, and now I go into the faculty mailboxes, and if somebody still has 4 there, I take them. I'm like, it's been like 3 weeks, and if you haven't taken them yet, I will be more than happy to have them. I also take all my junk mail and I put it in somebody else's box. It always has my name on it, and literally everybody on this campus who is a faculty member knows it's me. So, and then suddenly I end up with like everybody else's junk mail and mine. I'm like, oh, somebody else. Yeah, it makes me laugh. I don't know, I think you have to, there's, like, life is too rough. You have to be able to do it, and that makes me laugh. It's completely hard. Alright, statistic. One of these or many? Many. Again, a very simple example. If I randomly selected 5 of you, found out your average age, and then randomly selected another 5, found out that average age, are those 2 averages going to be the same? could they be the same?
Yes.
But there's nothing that forces them to be the same. This is why there's many of them. The notation for this, the X with a bar over it. And this is actually going to end up being a very common theme. Greek letters end up describing parameters. English letters end up describing statistics. It's usually how it's going to go. Alright. There, just to be thorough with this, and I'm never going to ask you this, there are 100 different types of averages. There's geometric averages, there's trimmed mean averages, there's all sorts of different averages. I just want to make this, right, this is an intro class. So let's just make this super simple. An average is an average, right? You add them all up, you divide by however many there are. Right? We don't have to worry about weights or any of that stuff. Right? We certainly can, but I don't want to. This will handle, this will be good enough for us for the entire rest of the term. Okay. You like this? Any questions about this? You want the exam, the entire exam to be 100 of these. Calculate this average. They're worth 35 points apiece. Wouldn't that be amazing? Except for you don't need it. Can't use a calculator on the first exam, so that might suck. Alright, standard deviation. Okay. This is going to require work. Yeah.
Mean deviation and then just standard deviation?
Right, there are two different numbers. Right, this is just the average, which describes the center. The standard deviation is going to be a completely other number. So that's why there's like, I put a dash there, but I probably should have put. Just because they're two different things.
Oh, yeah. Okay.
Alright. This is the definition part. And again, I'm never going to ask you what this definition is, but I think that it adds value here. Standard deviation is the average distance, all values, are from the mean. So this is why I say that whenever I think of standard deviation, I just think of spread. So this is an easier sort of explanation for this. So, how about this? What happens? What happens if standard deviation equals 0? There's no spread. That's literally what it means, right? Because if this guy right here is telling me that there's a distance, right? Standard deviation is describing a distance. So if it happens to be 0, it means that there's no distance. There is no spread. So what would that tell you about all the data points? It's all equal. They're all exactly the same. Same value for all the data. What happens if the standard deviation equals a negative number? No, because if it's 0, that means that all the values are the same, right? I actually put this question on the exam. What did you say? All the values are negative? Are negative. really, this is typically, like one of these is gonna show up on your exam. It'll give you guys a story problem, and I'll say, you calculated the standard deviation of, I can say 0, I can say a negative number, I can say a very large number, I can say a very small number. But this is typically, like I put this right here on the exam form, I think I make it like negative 2.5, or something like that. So then I have these multiple choice questions. And literally what she did is how I come up with my multiple choice answers. I'm like, oh, I understand why you would say that. That's wrong. Let me put it on an exam. So I actually get all of my multiple choice answers from students who believe and say with gumption that they are correct. That's the best way for me to come up with multiple choice answers. And also, how about this? What is the most commonly picked multiple choice answer?
C.
Yeah, except for I know that. And now you know that I know that. So now you don't know whether to choose C or not. Because I could have all of them be C, or I could have none of them be C, or I could just spatter some of them in there. Or what's the other one I heard? This one kid said, I just picked that one because it was the longest one. Really? That is genius. So now I just put a bunch of gibberish in one line and make it be like all the way across the page, and then have the answer be like something really short. I got him on like, he told me, he made the mistake of telling me after the first exam, so I'm like, special exam coming just for you. Alright, obviously it's not this one, right? Because that's what she said, and I already told her that it's wrong. Does standard deviation describe skew? Does it describe peaks, gaps, clusters, outliers, skew, symmetry? Does it say anything about that? No, all it does is describe spread. So, can it be this? No. No, it cannot be that. Because standard deviation does not describe skew. It just describes spread. I'll give you guys an example. Well, you already know it from up here, right? A very small standard deviation means that there's not a lot of variation. A very large standard deviation means that there's a lot of variation. But you don't know if there's gaps, clusters, outliers. You don't know any of that stuff. You just know that the values are very spread out. So what about this? All the values are below the average.
Could be that.
Think so?
I think I messed up. No.
So really think about this for a second. All the values are below the average. That would be like everybody in this class scoring a 74 on the first exam, but me telling you the average score was an 83. It's false. Kinda, yeah. So does this even make sense? No, an average should be a center value, something that ideally would be in the direct middle. And plus, it just doesn't make sense. If everybody here scored in the 70s, how can I have an average in the 80s? Right, just logically, that doesn't make any sense, right? So it cannot be this. So that leaves, and not only do you know this because I'm telling you this, but also, can a distance be negative? The distance cannot be negative, right? You can't go backwards. If we could, I would have a lot less miles on my vehicle. But even going backwards, you still put miles on it, right? When I drove here, and then I end up back at home, right, my net distance is still 0, but I certainly went someplace, and then I went back, right? So you're always going somewhere. So this is the only one that makes sense. Can a standard deviation be negative? No. What's the smallest it can be? 0. Right. The larger the standard deviation, I'll just tell you, the more spread. Everybody understand what it means when I say the more spread out the data? I can draw a kick-ass bell curve. Did I show you guys this last time?
Yes.
But they were bad. So a large standard deviation might be like this. Very spread out. Versus the smaller standard deviation. This means less spread. So So it might be something like this. Right? The larger the standard deviation, the more spread out the values. The smaller the standard deviation, the more tightly clustered it is. But I don't want you guys to think that it has to be a bell curve. Because have we described a bell curve yet in this class? What did you guys just describe? What was that? That was right skewed, right? So it could still be right skewed, left skewed, it could still have gaps, clusters, outliers, it could still have all that stuff, but I think visually it makes the most sense if I just draw it like this. That's a very simple explanation for it. The larger the standard deviation, the more spread out the values. The smaller the standard deviation, the more tightly clustered it is. Make sense? Alright, so let's do an example. You guys remember the first day example?
First day one.
I talked about the mean and the median. I gave you those two and I asked you which one would you prefer. What? Oh, those are ditto marks. Do you know what ditto marks are? Oh, okay. Yeah. Is this the first time I've done it this semester? Do you guys know what ditto marks are? Yeah, whatever's up here just comes down. It's like the old person version of copy paste. Yeah, no, like 3 years ago I had to explain this to somebody and they're like, I've never seen that ever. I'm like, really? And I'm like, how can you not have seen this? Like, I've typed everything my entire life on a screen. I'm like, makes complete and total sense. And I felt very old, but I totally get it, right? You've never seen it, so how would you possibly know this? Because I'm like, quotes? What quotes? I'm like, those are quotes. I was really confused there. Alright, so play off of the first example from that first day when I gave you the mean and the median, because those were two terms that I think that you guys knew. Now that we have the mean and the standard deviation, we can do a variation of this, which should make a little bit more sense. So let's say the average score 72 and a 62. And then, I haven't done the notation or anything yet, so. The standard deviation for this, let's make this one 8, and this one 18. So they both add up to 80, so that somebody's not like, I'm gonna pick B because it adds up to 80, and that one over there only adds up to 83. I don't know. I've had students that would do that. Ideally, I would like to make this guy right here 28. Adding them does not help. Okay? Does everybody understand this scenario? After you guys take your exam, I will give you the average and the standard deviation for how the entire class did. If I give you this, how do you feel? If I give you this, how do you feel?
Better way exam one.
Are you sure? Find your chum. Discuss. Get to the meat of this matter. Be like, I want one rocks. I want 2. 2 is awesome. This will show up on the exam.
Standard deviation, which is supposed to be an average of all the information, says that means everybody got a terrible score, and we got a 72. So, whereas the other one, if everybody got an average score of 28, we got a score of 62, it's good, but it's not as good as one. That's just my perspective. I'm like, well, what do you think?
So this one equals the average of the entire class.
Yeah, the standard deviation would be average distance of all the values.
Yeah, and this would be just the average of the entire class, right?
Yeah.
And you said, is the question like which one is better?
Actually, that's a good point, because if the standard deviation would be 8 points, right, and that means that almost everybody did closer to 72, whereas this one, everybody did a lot farther away, meaning it's a lot before and a lot after 62. But this is our score, right? You said this is our score?
I didn't hear him say that. That's why I'm a little confused.
I got that little symbol here, notation.
By the way, there's no right or wrong answer here.
Oh goodness.
Yeah, I think the mean is like the average of the population, right?
This is a complete personality test, is all this is.
So what was the question?
It's a
Wait, I
complete
heard the
personality test
question.
of what you're trying to gather out of this class. Both answers are absolutely 100% correct.
Okay, we'll just go with one then.
That's what I didn't like about this test. It's always right.
Yeah, welcome to the world of statistics. It's actually kind of good, right? Because you have to be able to understand someone else's point of view and be like, okay, I get that, and be cool with that. Alright, you guys want exam 1? Yeah? You like exam 1? You guys want exam 2? I do. Alright. Why do you want exam 1? Yeah.
Because the spread's lower, so the way that I'm interpreting the information given is that a smaller spread to me is almost like there's like fewer like gaps. So like you want to have a higher average there because you have a higher likelihood based on the population given or their sample given.
Yeah, like the way that I interpret this is who scored closer to 70, who scored closer to their average? Exam 1 or exam 2? Exam 1. If you're just trying to get through this class, I just want to pass. Please, dear Lord, pass. Which one are you more likely to pass with?
Exam 1.
Exam 1, because the standard deviation is very small and there's not a lot of distribution. There's not a lot of scores that are really, really high. There's not a lot of scores that are really, really low. They're all pretty tightly clustered around 72. Does that make sense? So if you're like, look, I just want to do this, then you want exam 1. If you are that, I am in PTK, I am going to get a 99.4% in this class, otherwise I cannot exist any other way, then what do you want?
Exam 2.
You want exam 2, because where exam 2, the scores are much more spread out, right? Which one are you more likely to get a higher score on, exam 1 or exam 2? Exam 2, because the standard deviation is much larger, so scores are much more spread out, and you're farther away from the average. And if you are that 99, I must get that, I am honor student, I have to get that in order to succeed in life, whatever, if you're that type of student, you actually don't want exam 1. Because yes, you passed with exam 1, but did you get an A?
No.
No. As for me, from my point of view, which one do I want? I want exam 1, right? Because what am I trying to do? I'm just trying to get you guys through this class. I know that people want A's. They're like, right, I get so many emails all the time, especially after exams. Can I take the exam again? Of course, what's my answer to that? No. But I totally understand why students ask that. But again, for me, I think and this is a good grade in this class is anything that's a C or higher. And I understand that that students aren't used to hearing that. But that's all that you need. The whole goal of college is to take the next class and not have to repeat the class before. So if you can take that next class without having to repeat it, then that to me is a success. That's why it's a C or higher. Does that kind of make sense? Unless you just want to graduate. If you're looking to just graduate, you just need a D. Right? That's all that matters. So all you need is a 60%. So does that still accomplish the goal? Yes. Does this kind of make sense? You guys understand the logic behind here? Alright, let's change this. This change the narrative?
No.
Find your chum, see if somebody's gonna change.
Well, it depends on the context.
This is your job. You're offered
This
jobs
is the
in two
example he
different
gave
markets.
day 1, remember?
One
was
job
here
has got
the
an
first
average
day.
salary of
I was not
72,000.
here.
The other job in another market has the average salary of 60,000.
He was saying that the first job that he got, the average salary was $72,000, but there were fewer jobs there. And then the other place where he was thinking about living, there was a lower salary of $62,000, but then there were a whole bunch of jobs there. You get what I'm saying? So which one would you want? Would you want to be someone who's making a whole bunch of money in an area where there's only a few jobs or less area or less, population? Or would you rather be making a little bit less money where there's a whole bunch of people making around that same amount of money?
It doesn't change the interpretation, no. That's why there's no right or wrong answer here.
Yeah.
This is seriously just a personality question. That's all that this is.
I'm gonna go with one.
I'm trying to make money.
Right, I told you guys about my background, right? So the reason why I came here, right, you told me there was 2 jobs, right? One in Coastal Carolina and then this one. The reason why I came here is because this offered tenure, promotion, union. So yeah, as long as I cover my material, I don't ever worry about my job, which is an amazing thing considering what just happened. Right? 2020 to 2022 was terrible for a lot of people. I didn't have to worry about it. That's a huge release off. So for me, 15 years ago, when I moved here, which one did I want? Just make me look skinny.
I wasn't no. I was looking at my face.
Oh, you're looking at yourself.
Oh yeah, I wasn't taking pictures of you.
15 years ago, which one did I want? I actually wanted job 1 because I want the security. Right? I have kids at home, they have all sorts of needs, and I have to be able to provide for them. So I want to make the most amount of money and be the most secure as I possibly can. Now that I'm older and my kids are gone, and if I ever moved off again, which one now am I taking? I'm taking job 2 because I'm damn good at what I do, and I have 20 years of experience in my back. Right? You guys understand the differences between the 2? So there's no right or wrong answer here. It's just a matter of perspective. That's what this class is. Right? We're interpreting these values in the best way that benefits you. That make sense? That's why I'm a firm believer in science, and yet I understand people who make different decisions than me, and that's fine because as long as they're following the science too, and they're making the best decision in terms of what is going on with their life. Right? I can't judge that. I need to understand that. Here, I completely understand both sides. It depends on who you are, what field you're going into, whether you want to move, whether you don't want to move, what your background is, what you're trying to do, and I can't judge any of that. So that's why I said that there's no right or wrong answer. Okay, you guys understand the difference? Alright, so let's start this. A population standard deviation. This is a sample. All right, population standard deviation. Parameter or statistic? Parameter. One or many? One. Notation? Zero with a very long tail on it. It's actually a lowercase sigma. This is the uppercase sigma in the Greek letter. That is a lowercase sigma. And yes, I will use that term. Most students just say that. The circle thing, that's literally what they say. Sample standard deviation. Parameter or statistic?
Statistic.
One or many? Notation is just a lowercase s. Okay, we know when you guys are done because I don't want you guys to write this part down. Unless you really want to know what the formula is, and you desperately need it in your notes. If you do, then by all means, write this down. But I don't know very many people, because you just don't have the mathematical background to understand all the stuff that are going to go. It's fine, you don't need to know that. You just need to know how to interpret what it is. All right, this guy. Yes, that is a giant square root, and yes, it's a giant square root on purpose. This is the formula. Again, I wouldn't write this down. The only reason why I'm telling you this is because over here, do I calculate this population standard, the population average and the sample average the same? Yes. Add them all up, divide by however many there are. Right? I don't care if it's a population or a sample. This is the same as this. Right? If I put this into any sort of software, I'm going to get up the same number every single time. Over here, any other way to calculate a population proportion and a sample proportion, or are they both exactly the same? They are the same. This one is different. So this formula for a population standard deviation is actually different than this formula, and it's off by a very, very small amount. So much so that I will get emails saying, I have put in standard deviation just like you told me. Why do I keep on getting it wrong? I'm off by just a little bit. What is my response going to that be? What is that kind of Yoda wordage?
We know what you said.
Okay, good. Because I was thinking about something else. When I was saying those words, I was thinking about something down the road. Right? When a student emails me and they're like, I'm putting in the standard deviation just like you showed me, but I'm off by a little bit. What am I doing wrong? What is my reply going to be? Which one are you doing? That's going to be here, right? I'm going to say, are you asked for a population standard deviation because and then you gave a sample, or were you asked for a sample and you gave a population? Because they are different. They are calculated different. There's different buttons. Back in the old day when I actually had students do all this stuff by a calculator, there's different sets of things there. You have to be looking for different things. Does this kind of make sense? That's why I've shown you both of these. Will I ask you ever what this formula is? No. Will I ask you ever what this formula is? No. Will I ask you, given a number summary, which one is better? Absolutely. I will ask you from a student who's just trying to pass this course, which exam would they want? Somebody who is the absolute best at their job, which job should they take? That's what I'm going to ask you. I'm not going to ask you to calculate this stuff. Okay? So, again, the only reason why I'm showing you this is because the two values are going to be different. And I'll show you guys where all this stuff is. Okay. Do we hate this?
Mm-hmm.
Yeah. This has got a major flaw, but yet it always cracks me up whenever students ask me. That's usually the very first question that students will ask after I pass back their exam, because they'll look at their score and they'll be like, what was the average? I'm like, do you really want to know what the average is? Because every single time I've taught this class, there is always a score in, let's say all of you guys scored in the 70s. Oh wait, what did I say? 80. Well, like I like you guys. We'll make it the 80s. You feel good about the 80s? I'm not giving you 90s. So the 80s are all that you're gonna get. Let's say everybody in here scored in the 80s, except for that person there. Let's say that they scored 42. What's that going to do to the average? It's going to bring it down. Is it going to bring it down by a little bit or a lot? It's going to bring it down by a lot. And I'm being very generous with the 42. I have given single-digit exam scores from students who have sat in class. Right? They just, I will never forget. It was that 204, your classroom. I don't know if you were there, but there was a girl who sat, so the teacher station here. She was the second row, right in over here. And I passed out the exam, and she was there for like 3 minutes. And then she literally started to And I mean, like, weep. I'm talking tears. I'm talking. There was a girl over here who got up and handed her a tissue. And then she, like, 10 minutes later came up and turned in her exam, and then she left. And they're like, aren't you gonna do anything about it? I'm like, no. She hadn't been in class in 3 weeks, and she spontaneously showed up on the day that I was giving the exam. Do I feel bad for her? No. She didn't come to class for 3 weeks. What did she think was gonna happen? So she spontaneously just showed up and had to take a test. She also she needed the class to go off to graduate school, but she told me at the beginning of the course. If you need this class to go off to graduate school, are you gonna miss 3 weeks of class? Every single day, taking all the notes, asking all the questions. So I don't feel bad for her. But how do you think that she scored on the exam? No, she did terrible.
Wait, like, did she graduate though?
No.
That was cute.
Right, so if all of you guys scored in the 80s, but let's make it really bad. That guy over there scored in the 7s. Scored a 7. Now what's that going to do to the average? It's going to go way down, right? Do you know what the exam scores are just from the average? No. You have no idea. So why do students ask, very first thing, what's the average? Because the average takes into account the bad scores, right? So over here, actually, let me write this. The mean and the standard deviation have a flaw. They have a flaw. In terms of all of your guys' exam scores, what is that 7 in relationship to? We used this vocabulary word last class. It begins with an O and ends with an outlier.
Outlier?
Yeah. I couldn't do the outlier without taking that O off. Right. So the flaw with this, outliers. And actually, and skew. If the distribution looks like this, and by the way, that's a kick-ass bell curve right there. If it looks like this, then absolutely we should be using the mean and the standard deviation. Because the mean is going to be right here, and the standard deviation is just going to describe it. But everything's tightly clustered, there's no skew one way or the other, there's no outliers. Everything looks very nice and normal. Right? So if it looks like this, then we should use a mean and standard deviation. For your guys' exam scores, with that example, everybody scored in the 80s, that one person scores in the 7s, does it look like this? No. That might look like this. Ouch. So should I use this for this type of distribution? No. So this is why I don't know, it really bothers me whenever stat classes start with the number summary. Because that's not the whole picture. The whole picture is we have to start with the distribution. That's why I spent all class, well really 2 classes, talking about graphs, right? Which type of graph is appropriate, and then let's describe it. Based upon that description, then let's choose the number summary that's most appropriate, right? If there's gaps, clusters, outliers, we don't want to do this. We need another number summary. That's going to be the third one. If it is a wonderful bell curve with a nice peak in the middle, no real outliers and no skew, then yes, then this is fine. So this is why whenever students ask me, what was the average? I'm like, you really want to know that? Because does the average do a good job of representing the middle value in that scenario? No. So we need another one. So this is the other one. This is the 5-number summary. Anything on enough? Get some numbers there. I always wanted to put that on a test, but I figured that's too mean. How many numbers on a 5-number summary? 8, 1, 2, 3. Just give it to you. But I thought that would be way too mean. Well, because I also know that, like, if I handed around a piece of paper right now that just had your name up at the top of it, would you guys all be like, oh, take attendance for something after you just sign your name, right? Isn't that what you would do?
Yeah.
But if I handed you a piece of paper, it said exam 1, I wrote name beside it, suddenly students go, oh shit. Does he want my name or his name? I don't even know what his name is. What name does he want here? Steve. I don't know. It never happens. As soon as I put this at the top of a piece of paper, students suddenly just become like you're like, anything I've done for the past 4 weeks is completely gone out of your mind. So I thought that like, the 5-number summary consists of the minimum and the maximum. Then the value directly in the middle is the median. The median is location based. And I'll give you guys an example here in a second. So this is where 50% is below this and 50% is above this value. Then between the minimum and the median is the lower quartile. Sometimes this is called Q1. This is where 25% is below this and 75% is above it. Yeah. Between the median and the max is the upper quartile. This is Q3. Where's Q2? It's the median. And if you literally think of this in terms of quartiles, it's very close to a quarter. This is 1 quarter, so 25% is below this. This is 2 quarters, so 50 cents is below this. And this is 3 quarters, so that means 75% is below this. And then the maximum. Okay, that's it.
That's 25?
25% below, this is 75% below.
Okay.
Oh, they're all right. They're in the same order. Okay, I don't remember your ages, so I made them all up. I don't think anybody in here said. Well, somebody is now.
I'll take it.
Okay, you be 70. I'll still be 62. I know that that's the age that I said. Alright, so let's say that this is the data set. So we can make this super easy. Where's the min and where's the max? Where's the min? Where's the max? Right? So with this, is there an outlier in this data set?
Yes.
Yes. Typically, and actually I explained this last class, where are the outliers located? At the ends. So, aren't the outliers going to be in the min and the max, always and forever? Which is fine, right? Because at least there that I will have an opportunity to determine whether it's an outlier or not, whereas with this, I have no idea, right? It's just two numbers, an average and a standard deviation. Right, so I don't even know if there's any outliers here. This one right here, I might be able to tell. Here's an interesting thing. Where's the median? Where's the value down the middle of this? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Falls between.
I made 10 data points here. So where's the median? It is not 5. People want to make it 5. But it is actually here. Since those two guys right there are both 20, then this is also a 20. Let me change it. Let me make this guy right here 20. Now what is the median? 20.5. Is 20.5 actually anybody's age? No. But this is still going to be the median. Because this is the value that splits the data in half. There are 5 data points that are below this, and there are 5 data points above this. But even though that there are 10 values, it's not the fifth. Because if it was the fifth, this would mean that I have 5 values above it and 4 values below it, and that's not the middle. Right, does that make sense?
Mm-hmm.
Long time ago, whenever I made students do this by hand, I would literally have students go. Yeah, I know, especially whenever I made it like 47 data
I would like
points.
crossing it out.
I know, I didn't like the class.
I didn't do this.
I will not ask you guys to do that. We will have, again, I'm not gonna, you don't need a calculator for the first exam, so it should be pretty straightforward. But what I want to get across here, this value isn't even in the data set, but it is the one that splits it in half. Where's the lower quartile? So now I have these values. 1, 2, 3, 4, 5. It is actually this guy right here is Q1. It actually is a number now. Although it's weird because there are 5 data sets here, but what's the, if you divide 5 by 2, you don't get 3. But if I make it the fifth, then I have 2 values below it, 2 values between it and the median. What about over here? 23. This is Q3. So with this, all of these, like I said, location based. So what I mean by that, let's say that I had 10 exam scores up here, right? And I put them all in order. The minimum is going to be the first value. The maximum is going to be the last value. The median is going to be between the 5th and the 6th value. The first quartile is going to be the 3rd. And the 3rd quartile is going to be the 8th. I don't care what the data points are. If there are 10 data values, that's where the 5-number summary is going to happen. Regardless of whatever the data actually is. It is all dependent upon the location and how many data points there are. Does that make sense? So now, I don't care about the person who got the 7. Where is that 7 going to show up? Here. Where is everybody else going to show up? All this stuff right here, right? The first quartile, the 3rd quartile, and then I can start to look at these differences. For example, what is there? Between median and Q1 is, what is that? 2.5? 2.5 here. Right, do you guys see what I've done? Between the median and Q1, right? 20.5 and 18 is a difference of 2.5 years. This turns out to be 25% of the data. 25% of the data is between the Q1 and the median. So, and that only has a spread of 2.5 years. You guys see? Between Q3 and the max. Between Q3 and max. What's the difference there?
39.
39 years in between Q3 and the max. But what percentage of data is that? It's still gonna be 25%, because what's the difference between the Q3 and the max? That's still 25% of the data is in between Q3 and the max, 25% of the data is in between Q1 and the median. Right? This is 25%. This is 25%. Which one's got more spread? Q3. Do you guys see how I can use the fact that there's 25% between each one of these right here to determine which one is more spread out? So this is going to allow me to say, oh, well, there's 39 years. In this quartile right here, there's going to be a massive outlier. Compared to, what, this right here is only going to have another 2.5. That's why I didn't pick this one. This one right here is going to have, what, 1? It's got a difference of 1. It's got a difference of 2.5. That's got a difference of 2.5. This one's got a difference of 3 or 39. So this one right here is really, really spread out, which is leading me more to say there's an outlier on the upper edge. You guys see what I'm doing here? There is the inner quartile range. This is the IQ line. This is Q3 minus Q1. And the reason why this guy is important is because this is 50% of the data. So if I'm looking at your guys' exam scores and I say, oh, well, 50% of my class scored within 4 points of each other, I'm feeling pretty good about that. Because that's a large chunk of it. Okay, this parable. This is location based. This is the term for this is resistant. To outliers and skew. It is resistant to outliers and skew. So what I mean by that is, let's say I accidentally put a 1 in front of here. Does that change the 5-number summary at all? Just the maximum though, right? Nothing else? How would changing this guy right here, right, because I've done this before, I put in scores for your guys' exams, and suddenly I give one student 784 points. Because I'm stupid and I have bad fingers. The student doesn't really care. But suddenly I look at my average score and it's like 503, and I'm like, oh, well, that's not right. Right? Because what is this one super high score going to do to the average? Bring it way up. What's it going to do to the standard deviation? Really spread that thing out, right? Because outliers and skew have a heavy influence on the mean and the standard deviation. So, if it looks like this, if I have a skew, I don't want to do the mean and standard deviation. This is why I'm always, why do students ask me this? Why do students ask? Actually, I think I know what. Because you guys have been doing an average since you guys were 3. Right, and that's the one value that you guys have always done, one that you're very familiar with. Alright. Mean. Where's the median? Did you have a question?
I got it, thank you.
Where's the median? It should be in the middle, right? So if I consider this to be like I'm coloring it, right? The mean is typically in the middle of a nice, evenly spaced out bell curve. So 50% of the data is above it and 50% of the data is below it. So these two guys right here are roughly the same number. Yeah, but I changed it.
I know, I don't know that.
Didn't I change the clock and then I hung it up? Did I put it an hour behind? Like, I literally put a battery in it and hung that there.
I feel like it was the right time all this time.
No, I came in here like a little bit before class, I said 3 something. I'm really confused. Huh? No, my watch has definitely got the right time. I paid too much money for my watch to tell me the wrong time. That, I put a $3 battery, 3-cent battery that I found in one of the classrooms in that thing, so that thing is definitely on.
That's probably why I did that.
Right, Steve, left you. What is this? Right, Steve, left you.
Less,
This is left skew.
less skewed.
Would the average value now be at the top of this peak?
No,
No. Where's the average going to go?
down the slope.
It's going to go down. So the average might be here. Right? Where's the median? Think of this in terms of area. If I split this area in half, where would I split it in half at?
Like slightly, yeah, so it's the
Maybe something like this? That kind of split it? Maybe? A little bit off from the top there? So, if the mean is less than the median, you know that the graph is left skewed. Wait,
Is the mean is what?
less than the median, then it's left skewed. What type of distribution is this? Left or right skewed?
Right
This
skewed.
is right skewed. Where's the average now?
going down the slope to the right.
It's still going to be going like this. Right? Where's the median? It's going to be on the left. So now, if the median is less than the mean, what type of distribution do I have? It's not right skewed. An easier way for me to remember this. The mean will follow the outliers, it'll follow the tail. It's an easier explanation. Right, so if it's left skewed, I know that the mean is going to be more to the left. If it is right skewed, I know the mean is going to be more to the right. If it is symmetrical, then it's going to be directly down the middle, and they're going to be almost on top of one another. Alright, so let me show you guys this, because you're gonna need a chum. This is going to show up, again, on the next exam. It is going to show up on the final exam too, because this is a really good trial for that. So once this thing forms up. Oh, let me make it available, so. For those of you with fun eyes. So in Blackboard, there is, I literally just downloaded it. So there's down there at the bottom, it actually has a number summary. Has, I don't care about the variation handout yet, so we will cover that. Oh, we have plenty of time. We've only been in this class for 10 minutes. It certainly feels like a hell of a lot longer. Plus, is like the heater on over there?
I think so.
Seriously. I'm not standing over there anymore. I'm gonna start writing backwards from over here. Good luck. Alright, the box plot and number summaries PDF. That's the one I'm looking at. So it should look like this. I haven't got to the box plots yet. I don't care about the box plots. I'm going to do that next class. And then I'll show you guys how to do all this stuff on Cengage next class as well. Down here at the bottom, this is the one that I want to talk about right now. I have, like I said, I have literally put this guy on an exam, word for word, identical. and this is how it's going to show up on your guys' exam. Part A is worth 2 points, part B is worth 2 points, part C is worth 4 points. So it says the following table represents the number of summaries for the profit obtained in reselling houses, and reselling, resale, of 45 houses in 2 different, but very large markets. So I have these number summaries. Part A, what is the proper deviation? The mean and standard deviation. You guys want to show them? Actually, you guys try to do A and B, and then we'll talk about C. A and B, you guys should be able to handle with what I have erased, and then what I have on the board directly behind you.
Okay, so the notation is.
A and B. What is the mean and standard deviation? What is the notation? What are you doing? What are you doing?
Here it is.
Alright, so let me do part A. Let me do half of part A with you. Do you want me to do the mean or the standard deviation?
Notation.
I'm only doing one. Alright, I will do the average.
Okay.
Right, it is asking for the notation. What notation should be used for this problem? So for the average, I either have to choose mu, that's that fancy M, or x bar. So that's one of the two answers that's there. It's either going to be a mu or an x bar. I have to determine which one it is. So I have to determine, is this a sample or is this a population? Up in the story, it says, obtained in resale of 45 houses from a very large market. Is that a sample or is that a population? That is a sample. What is the notation for average for a sample average? X bar. Part A should have an X bar. And then what is the notation for sample standard deviation? Is yes. Yes. Part A should have X bar and S. Because this is a sample. It's a sample that is, right, so we are doing what is the proper notation for the average and the standard deviation. The average here is a sample average, so that should be an X bar. It is a sample standard deviation, so it should be an S. Those are the notations that we use for average and standard deviation. Alright, for B. Look at market 2. Look at the mean. Look at the median. Alright, look, we just drew this right up here. Up here somewhere.
590 minimum. 1100 or so. I think it's symmetric, I think. Because look, this is almost 100. That's almost 1. Median is 33. No.
Market
Most of them are here. So it's going to be left skew.
For market
Left
2, the mean is 35,000. the median is essentially 34,000. So according to those two values,
Yeah.
is the distribution going to be symmetrical, right skewed, or left skewed? If students put right skewed, I would count that as correct. Okay.
Yeah, that's
Alright.
If students put symmetrical, I would count that as correct. If somebody put left skewed, that's just wrong.
I said right school, then you said margin 2, so I don't know that.
No, I wasn't gonna mention it. You were looking at it. So let me explain the logic here. Is 33,800 practically the same as 35,000?
Yeah.
I mean, when it's not my money, it certainly is about the same. So if this is the profit, the median profit is roughly 38,000, so 34,000, and this is roughly 35,000. As an investor or somebody who's looking to make money, would you be like, no, that's massively different between 34,000 and 35,000? And if you said yes, that those two values are really, really different, then your answer should be that it is right skewed. Because you believe the mean is significantly larger than the median, right? You believe 35,000 is significantly larger than 34,000, which is fine, that it's right skewed.
So if the mean is larger than the median, then it's
Right skewed. Right skewed. Did she say left?
right to right.
Okay. I thought I heard left.
Sorry.
If you believe that 35,000 and 34,000, yeah, they're both about the same. Right? If you believe that they are both about the same, then you would say that the graph is symmetrical. That's here. Oh, that's here. That's why I put the little squigglies. They're about the same, then it should be symmetrical. This one, the mean is larger than the median. So, you believe that this is right skewed. This makes sense?
Yes.
Yeah.
So this is why it's 2 points. I'm just asking you. What I would ask for there is, since the mean is larger than the median, it is right skewed. Right? You give what the skew is, and then you give the reason. Since the mean is about the same as the median, it is symmetrical. Does this make sense? If you put left skewed, I quit reading and I put -2. Because anything you say beyond that is wrong. Alright, letter C. This is a brand new company with very little money, and they're looking to begin their business with the biggest potential for profit. Looking at the two markets, which one has got the biggest potential for profit? Why?
But there's a higher risk.
Because why?
Percentage of the houses are lower value.
There's a higher risk.
How? Right. How are you assessing risk?
You'll get
Yes. Which, over here, what does standard deviation mean?
spread.
Spread. Which one is more spread out? Market 2. Which ones are farther away from the average? Market 2, because the standard deviation is larger. That is exactly the same, it has exactly the same meaning as the jobs example. The exams example, yeah.
Would that be also synonymous with volatility?
Yeah. And that's exactly what this is, right? So the reason why this is so low is because this is very predictable. Right? If you ever, so I'm terrible, actually, I'm awesome at fantasy football because I know statistics, I understand it's all about consistency, and that's what standard deviation is telling me. The smaller the standard deviation, the more consistent it is. The larger the standard deviation, the more volatile it is. And with volatility comes a better chance of getting a higher profit. Does that make sense? We'll finish this after